Welcome back, all my aspiring mathematicians. Today I'm going to show you how to find the area of a triangle when it is graphed on the set of axes. And none of the lengths of the sides of the triangle is given to you. So I'm going to show you 4 ways that you can achieve the area of this triangle. The first method is that we are going to enclose this triangle into another polygon, and that polygon could either be a square or it could be a rectangle. So let's get right into it. So you have the triangle here, and I need to enclose that. So I'm going to draw another polygon that is going to enclose this triangle. And notice what I'm doing here. I need to go all the way out to the edge because I need to enclose that side piece or that vertex of this part of the triangle. And I need to come straight down with this side. And I need to come down to this last one right here. And I need to go across. And I need to do the same thing for this side. After you have enclosed this triangle into this polygon, you will notice that you have 3 right triangles that are going to be beside each of the segment of the length of the triangle. So you have triangle 1 here, triangle 2, and triangle 3. So now you're going to count the units for each of the other 2 lengths of the triangle. So 1, 2, 3, this is 3 here, and coming down 1, 2, 3, 4, 5, 6. I got 6 here. And then let's go for triangle 2. I'm going to count. That's 2, 4, 6, 8. This is 9. And coming down 2, 4, 6, 8, 10, 12. So this is 12. Let's do the same for triangle 3. So we have 2, 4, 6. And going across 2, 4, 6, 8, 10, 12. You will notice now, because this is a 12 on the outside, so let's put it there instead of putting it right here. You will now notice that this is actually a square that is enclosing the triangle, and it is not a rectangle. In some instances, you might find that it is a rectangle that is going to enclose a triangle. From this enclosure, you can now find the area of each of the 3 triangles that are around the main triangle. From prior knowledge, we should recall that the area of a triangle is equals to half base times height. So what we're going to do next is that we are going to find the area of each of these 3 triangles that are enclosing the main triangle. So let's first start with the area of triangle 1. We are always going to write our formula, which is half the base times height. The base here is 3 and the height there is 6. Okay? So we are going to work this out, and half of 18 is going to be 9. So the area of triangle 1 is 9 square units, and because we know that when we are finding the area of any given figure, the units is always going to be square units. If it is given to you in centimeters or inches, then it is going to be square centimeter or square inches. We now need to calculate the area of triangle 2. So let's get right into it. Area of triangle, and this is my symbol for triangle 2. Still, we write our formula, half base times height. And we know triangle 2, we have area is half of 9 times 12. And so we end up with area is going to be half of 108. Area for triangle 2 is going to be 54 square units. And make sure you are using your square there for your square units. So now that we have that, we are now going to go to the third step, which is to find the area of triangle 3. area of triangle 3, number 3, again, half base times height, so we're going to put in our base as 12 and our height as 6. So area is equals to half of 6 times 12 is going to be 72, and the area of triangle 3 is going to be 36u squared. So we're not done. What we need to do now, we are going to add the total of all 3 triangles. So the total of triangle 1, 2, and 3 is going to be, we're going to add them. We have 1 is 9 units plus 54 plus 36. And so we will end up getting here 99 u squared. So that's the total area of the triangle all around. We now have to find the area of the square because it is a square that is enclosing the triangle. So the area of a square we know is going to be length times width, or just simply whatever unit is each side measure to the second power. So the area of the square, and I'm going to draw a square here, is going to be, we have 12 times 12 because that's what it is. So area of the square is going to be 144 square units. Now we're not finished. We are going to now find the actual area of the triangle. So we're going to have area of triangle is equals to the area of the square, which is area of the square minus the total area of all 3 triangles. So we have 144 minus 99, and that is going to give you 45u squared. And that is the area of the triangle that is given to us. So this is one way you can find the area of this triangle that is given to you when none of the lengths are given to you, and you need to figure out how you are going to find it when it is graphed on the axis. So now let's get into the second method. The second method is to use the Pythagorean theorem formula to find the lengths of the side and then to find the area of the triangle. We have here leg, we can call this leg 1, and then this would be leg 3. So leg 1, using the Pythagorean theorem formula, which is going to be c squared equals a squared plus b squared. We're going to find the length here. So we will notice in this situation, because we have this triangle that is right here, which is triangle 1, we can say that this would be one leg, this would be the other leg, and this would be the hypotenuse, which would be AB. We're going to say AB square is equal to, and we have 6 square plus 3 square. And AB square is equals to 36 plus 9, hence AB square is equals to 45, and AB is equals to the square root of 45. And we can break down the square root of 45 to have it being square root of 9 and square root of 5. So AB is going to be 3 radical 5. That is the length of AB. So the next step is to find the length of BC. And in order to find the length of BC, we are still going to use the Pythagorean theorem formula, and BC square is equal to 12 square plus 6 square. And it doesn't matter which one you put first. They're both the legs, so it doesn't matter in this case, okay? So BC square is equals to 144 plus 36, and BC square is equals to 180. And to find BC, we're going to find the square root of 180. Now the square root of 180, this is irrational and it can be broken down. If you need help on doing that, you can go back and watch my video right here, and that will help you to break down irrational numbers. So now we will have the square root of 36 and the square root of 5, because 5 times 36 is going to be 180. Now you can further break it down and say the square root of 36 is going to be 6, and then you have your radical 5. Now that you have both lengths, you can go ahead now and find the area of the triangle by using the formula, which is area of a triangle, which is A equals the half base times height. Right now you have the base and the height. So area is equals to half of 3 radical 5 times 6 radical 5. And you will further multiply this. This is going to be 18 radical 5 to the second power, right? Don't forget that because you're multiplying radical 5 by radical 5. And so you will get A equals half of 18 times 5. Okay, and then area is going to be half of 18 times 5. This is going to be 90, so half of 90 is going to be 45. So the area is equals to 45u squared. And you will notice here that it is the same answer that we got previously. So this is the second method of finding the area of this given triangle. Now the third method is to use the distance formula. So let me show you how to apply that. So in applying the distance formula to find the area of this triangle, we first have to find what the coordinates are for each of these triangles. So we have to look on each one of these points and determine the coordinates. E is located at -5, 1. And A is located at -2, 7. And C is located at 7, -5. So you have to find the coordinates first of the location of all the 3 vertices of that triangle. Now we can apply our distance formula to find that. And the distance formula is D equal the square root of x2 coordinate minus x1 coordinate, raising that to the second power, plus y2 coordinate minus y1 coordinate, and raising that also to the second power. And we're going to find the distance or the length of AB. So if we find the length of AB, okay, using the distance formula, then we will use the coordinates. And we have the coordinates here. So AB, we could say that this is x1, this is y1, this is x2, this is y2. So we are taking x2, which is -5, and we're subtracting -2 from that. We notice we have 2 negative signs side by side. We're going to change it to a plus sign there. And we're going to raise that to the second power and add that to y2 coordinates is 1 minus 7, and raise that to the second power. Now we are going to continue with this, and we will notice that -5 plus 2 is going to be -3 to the second power, plus 1 minus 7 is going to be -6 to the second power. And we will continue. Square root of -3 to the second power is 9, plus -6 to the second power is 36. So AB is equals to the square root of 45, and we should break this down again, and we will get radical 9 and radical 5, so that will give us AB is 3 radical 5. You will notice that is exactly what we got when we first found what the other leg was. Then we will still use the distance formula and apply it to find the length of BC. So we are going to find BC now. And the formula is here. I'm not going to rewrite everything. I'm just going to plug in my coordinates. So now because I'm finding BC, I'm going to make this x1 and y1, and I'm going to make this x2 and y2. You just have to be careful there. So x2 is 7 minus -5, raise it to the second power, and y2 is -5 minus 1, raise it to the second power. So BC is going to be square root of, this is going to be a plus sign, okay, two negative signs side by side is going to be a plus sign. So we have 12 to the second power plus, we're finding now this is going to be negative 6 to the second power, which that is going to be 36. So BC is equals to square root of 144 plus 36. So BC is equals to the square root of 180. And we also need to break this down as radical 36 and radical 5. And BC is equals to 6 radical 5. And we will go back and apply the formula for the area of a triangle, which is half the base times height. So area is equals to half of 3 radical 5 times 6 radical 5. Area equals half 18 radical 5 to the second power. So area is equals to half. We can do 18 times 5, which is area is equals to 9 times 5. So area of the triangle is equal to 45u squared. This is the third method to find the area of the triangle. If you need extra help on how to apply the distance formula, you can go back and watch my video on the distance formula, and that will help you tremendously. Let's get into the fourth method of how to find the area of a given triangle. This fourth method is what we call the shoelace method. And there is a formula for the shoelace method, and the formula is as follows. The shoelace formula is half of, and we are taking now our x1 coordinate with our y2 coordinate plus, we're taking our x2 coordinate and our y3 coordinate plus x3 coordinate and y1 coordinate. And we're going to subtract the y1 coordinate and the x2 coordinate plus y2 coordinate and x3 coordinate plus y3 coordinate and the x1 coordinate. And this is what the formula is. It is simple when you are using it to find the area of a triangle, but you can also use the shoelace formula here to find the area of a rectangle if the coordinates are given to you. We already established the coordinates when we were applying the distance formula, and we can use that to apply it to the shoelace formula. So let's get right into using the shoelace formula to find the area of this triangle. We can label our coordinates accordingly. So because I have x1, y1 here and I have x2, y2 here, then I can literally call this one up here x3, y3. So just be careful with what you're doing. And it doesn't matter. You could have started with this and coming all the way around, say x1, y1, x2, y2, and then x3, y3. So let's get started. So I have my formula here, and I'm going to substitute my numbers, okay? So the area is equals to half, and I'm using the square parentheses because that is including a lot of parentheses going on inside of that. So now I'm going to do this side, which is the plus side, and then minus this side, okay? So x1 is -5, and I'm going to have -5 times y2. y2 is -5, okay? Plus x2, which is 7. And that 7 is now going to be multiplied onto x3, which is also 7. Plus x3, which is -2, and it's going to be multiplied onto y1, which is 1. y1 is 1 times x2, which is 7, plus y2, which is -5 times x3, which is -2, plus y3, which is 7, times x1, which is negative 5. Now I'm going to have that, and I'm also going to have the big square bracket. Okay? So let's do the math. So I have A is equals to half of negative 5 times negative 5 is going to be 25, plus 7 times 7 is 49, plus negative 2. So I'm going to put that in parentheses there just to show you that, okay? All of this, and then subtract 7, and this is going to be positive 10, and then this is going to be negative 35. Okay? And we're not done. We have to keep going to the next part. So 25 plus 49 plus negative 2. So we can say 25 plus 47, right, is going to give you 72. This is going to be 17 minus 35, which is going to be negative 18. And this is what it looks like. So now we have A equals half of these two negative signs here side by side is now going to turn into a positive sign. 72 plus 18, which is going to be 90. All right, so that's what it's going to be. And half of 90 is going to be 45. So it's going to be 45u squared. And that's your answer. If you notice, on all four methods, you still arrived at the same answer, which is 45 square units. So area is going to be in square units and volume would be in cubic units. So in conclusion, now that you know how to apply all of these 4 steps to find the area of a given triangle when it is given to you on a coordinate plane or on axis, and there is no coordinate given to you, no measurements that is given to you for either of the lengths, then you have to apply one of the 4 methods that I just illustrated to you to find the area of that triangle. So in conclusion, now that you know how to apply all of the 4 methods that I just taught you, the 4 methods are enclosing the triangle in a square or a rectangle, depending on the shape of the triangle. And the second method was to use the Pythagorean theorem formula to find 2 of the lengths and then apply the formula for the area of a triangle. And the third method was to use the distance formula to find the length of 2 of the segments and then to find the area of this triangle. You can also use the shoelace method to find the area of a 4-sided figure. You will simply apply the 4th coordinate to your formula. With that being said, if you have not yet subscribed to my channel, what are you waiting for? Go ahead and hit that subscribe button. And while you're at it, please like the video and share it with others around the world so they too can be successful on the next math problem like this when they're given to find the area of a triangle. Just think outside the box and apply any of these 4 methods that is easier for you to handle. Thank you for watching and see you soon on the next video to come. Bye now.